Hello everyone, this is Mr. Kesnick, making this for section P5 for pre-calculus. So we're going to look at doing interval notation, and interval notation should be something that's new, but to look back in the context of doing simple number lines that you guys should be used to. So a simple number line for me would be sticking 6 in the middle. You know that it doesn't have the equal sign, so it's an open circle. And then you're shading right. Alright, this one, try and get through these as quick as we can, meaning because it should just be review. So that would be open circle, and you're shading left. This one now has an equal sign, so it should be a closed circle, shading left. And this one should be closed circle, and you're shading right. Okay? I'm going to come back to those in a minute. We're not done with them. These ones, I think you only need to go as complicated as going -2, 6. They're both open, and because X is in between them, then you shade in between them. Okay? So we've got the same two numbers. I'm not trying to change the numbers to make that's what's different. I'm trying to just change the signs. So they're both closed, and you're shading in between. So there you go. Alright, sorry it looks extra sloppy. This slate is being a little awkward for me today. So, -2, 6, this one's open, this one's closed, and you're shading in between. Okay? Let's see, this is a typo on my part, it's the same thing as that one. I meant to put the inequality, or sorry, the equal sign on that inequality. So graphing that one, -2, 6, this one would be open, this one would be closed, and you shade it in between. Okay. Now, to go back to these first ones, how the book is going to suggest that you do this is using a different symbol for open versus closed. I don't particularly find this useful, and it still isn't doing interval notation, which is where we're going with it, but I will get you there momentarily. So, 6. Instead of having an open circle, they're going to use an open paren facing in the direction that it's shaded. So your answer would look like this. This one, 6, an open paren to symbolize you're not including it, shading left. This one, when you have a closed circle, it's going to be a bracket facing in the direction that it's opening, shading left. So this one would be a bracket facing right. So then these ones down here, -2, 6, it would be a paren facing this way, a paren facing that way. Sorry, I'm a little bit off there. Shaded in between. Okay. Where this would be a bracket between them. -2, 6, bracket, bracket, shade between. Okay, so where all this is going though, where I need to take you with it is, this still is an interval notation. So instead of writing this by graphing at all, skip the whole graphing thing altogether, and what you're doing is there's a parenthesis that tells you you don't include it, and then you're going to go all the way off to infinity to the right. And because infinity is unending, it's unbounded, there's no end to it, we're going to also always use a parenthesis to capture infinity, rather than a bracket to capture infinity. The bracket would mean you got there, and you didn't get there, because it's infinity. You write it from left to right. I started at 6 and went right. This one, I'm starting at -infinity, and I'm going to 6. And again, I'm using the paren at either positive or negative infinity. This has an open circle, so I use the paren. This one's starting at -6, so I use a paren. But at 6, I have a bracket. This one's starting at 6 and going to positive infinity. Okay? This would be -2, 6. Ugh, sorry about that. Parens on both sides. This would be brackets on both sides. Sorry, my bracket is getting... I should borrow some off of that and put it on this one. Okay. This would be bracket at -2, 6, paren. And this is paren, -2, 6, bracket. So that is interval notation, and that's what I'm looking for you guys to express your answers in your homework. And in the future too, write stuff in interval notation. Okay. We haven't looked at what it's an OR scenario, how to do that. Draw this on a number line. So you'd have 4 closed going left. You'd have 6 closed going right. So they're shaded away from each other. When they're shaded away, it's an OR. You have to have the word OR between them. So writing this with interval notation, -infinity to 4 bracket or oopsie doopsies. We've got bracket 6 going to infinity. Okay. The only difference with these two is it doesn't have the equal sign with it. So the answers, I mean, that's the only thing that's changing. The answer for this would be -infinity 4 or 6 with a paren to infinity. Okay. That's the only difference between these two statements. Okay, is that you don't have the brackets. It's the same numbers again. So the left one is going to have -infinity to 4 without the bracket, or, and so I guess I'll squeeze into this space. Bracket 6 infinity. Okay. These two symbols are just going to switch, the brackets and the parens. So you'd have -infinity. Let me start over further. I know I'm going to run out. Oops, I don't want this. Okay. Let's see. So -infinity is where you're starting. You're going up to 4. You're including it, or you're starting at 6 but not including it, going to infinity. Okay. So that's just simple interval notation. Now to use this in actual section P5. The book is going to ask you to sketch these things on a number line. I'm not looking for you to do that. I'm just looking for you to tell me the answer in interval notation. So to me, you guys know, you subtract the 2 first, you get 3x greater than 5, you divide by 3. Okay, this should be all old school stuff, like, yeah, we got that. Now tell me the answer in interval notation. So you'd go 5/3, infinity, boom, you're done. That's how I want you to see, to display your answer. When you guys have a double-sided inequality, you'd start by subtracting 2. So you'd have -6 less than or equal to 3x less than or equal to 6. Then divide everybody by 3. So you'd have -2 less than or equal to x less than or equal to 2. And so that would be -2, 2, both in brackets. Heck of a bracket. Okay? Start by multiplying everybody by 5. So times 5, times 5, times 5 in the middle. So then the 5 cancels out. So you'd have -10 less than 2x plus 3 less than or equal to 30. Subtract the 3 from everybody. It's supposed to be a 3. -13 less than 2x less than or equal to 27. Then you'd have to divide everybody by 2. They aren't reducing. Doesn't have a parenthesis, or sorry, doesn't have an equal, has an equals, so this would be paren, -13, and 27 over 2, bracket. Okay. A reminder here, when you guys go and divide by -3, remember the inequality also has to turn around. Okay. So this would be -infinity to -2, bracket. All right. Okay, solving with absolute values. You guys learned that the first time you do this, there's 2 equations you have to set up. And the first equation you set up is you just take the bars off and solve it. -10, -10, 2x equals -5, divide by 2, divide by 2, fantastic, x is equal to -5/2. That's one answer. The reason that you just wrote this down without the print or without the absolute value bars is because you assumed what's inside is positive. So whenever you have a number, I don't know, 72, that's positive inside, you just take the bars off. So we first assumed what's in here is positive, so the bars just came off and we solved it. Enough said. But what if what's inside is negative? How do you force it positive? Actually, what you're doing to get that to become positive 72 is you're multiplying it by negative 1. That's what happens when you take the bars off if what's inside is negative. First time around, we assumed what's in here is positive, so we just took the bars off. Second time around, I have to assume the, oops, I don't know why I wrote 25. We have to assume the value of what's inside there is negative, and we have to force it positive. So we're going to multiply it by negative 1, and it still equals 5. You could distribute this inside, or you could just divide it out, which is a little cleaner. Okay, that's a plus. Kind of sloppy of me. Here we go. So what I want you to notice here is this equation here compared to that one is the second equation, all you did was make the sign on the other side negative. Why? That's going to be a big deal this year. Why? Why did you do that? Because you assumed what's in here was negative. And to force it positive, you had to multiply it by negative 1. Then you move the negative 1 over. In all your prior classes, all you did was just set these two up without generally understanding why you're doing it. And that's a big deal. We need to start understanding why you do stuff, not just do it. Then you went ahead and solved it. 2x is equal to negative 15. Then you divide by 2. And this idea of moving the negative 1 over is going to be particularly important now that we're sitting here with inequalities. First time around, you take the bars off because you assume the value of that is positive. Second time around, you take the bars off, but you have to assume the value of this is negative. So you multiply it by negative 1. Divide out the negative 1. When you do that, the inequality has to turn around. So you have 2x plus 10 is less than or equal to. You change the direction, you change the sense of the inequality, and make what's on the other side negative. And now you solve both of these. Subtract the 10. 2x greater than or equal to negative 4. X is greater than or equal to negative 2. Subtract the 10. Negative 16, divide by 2, x is less than or equal to negative 8. Now for me, I'm definitely a little bit challenged in seeing these visually, so I'm just going to take a second and draw it. You're closed left, closed right, so that's an or statement between these two things. So when you go to write them, I'm going to write negative infinity to negative 8, and it's closed, so bracket, or, second of an or, sorry about that, and bracket negative 2 infinity. So that would be your answer for this problem. You have to set up two different things. I kind of squished in the space over here, so I'm going to clear it and do this one. Take the bars off. Take the bars off again. Yep, there's a negative 1 that you're going to end up dividing over, so it changes the direction of the inequality and make what's on the other side negative. Now solve them both. Subtract the 10. 2x is less than negative 2. That's a 10. Divide by 2. X is less than negative 1. Subtract the 10. 2x is greater than negative 18. Divide by 2. X is greater than negative 9. So on a number line, smaller number left, bigger number right, they're both going to be open. You're bigger than negative 9, smaller than negative 1, so you're in between. So I can write it in the same order. Oops, I was going to do a bracket. Parenthesis, negative 9, negative 1, paren. And that would be your answer. Okay. On this, sure, you can do it the same way. Set it up, plus 10, less than or equal to negative 4. 2x plus 10, change the direction of the inequality, change the sign on the other side, because it already was negative, so we're changing the sign on it. Okay, subtract the 10, 2x less than or equal to negative 14 divided by 2, x is less than or equal to negative 7. Go to this one, subtract the 10, 2x greater than or equal to negative 6, divide the 2, x is greater than or equal to negative 3, and then I'm going to look at that on a number line. There's negative 7, there's negative 3, less than or equal to, so closed, shaded left, closed, shaded right. But I'm going to pick a number and check it in the original because I want to show you something here. This number line continues. I just have to pick something that's in the shaded region. 0 is in the shaded region up here. 0 is. Okay. So I'm going to pick 0 because that would be a super easy number to fill in. 2 times 0 plus 10 in absolute value. 2 times 0 is 0, so the absolute value of 10 is 10. Is 10 less than or equal to negative 4? Heavens no, it's not. This is a garbage answer. These are not solution. I know I didn't check that one, but they're not solutions to it. The reason is, go back to this original equation. And this is the point of why I'm putting this here for you is, sometimes your algebra is going to work out just fine, but the question itself is bogus. You have the absolute value of something, and you're asked, when is it less than or equal to a negative number? What do absolute values do? They force things positive. When is something positive less than or equal to something negative? Never. There is no solution to this problem. There isn't one. Just because the algebra works doesn't mean you have an answer, because the question is bogus. So I'm trying to get you to step back and look at the problem and watch it, rather than just blindly just plowing through the algebra. Look and see what it's asking. So like, for example, this one. This is forced positive because of the absolute value. When is that greater than or equal to negative 3? Or if I do it a little more generically, when is something positive greater than or equal to something negative? Isn't this always true? No matter what? Isn't something positive always bigger than something negative? Yeah. So the answer for this one is all real numbers. Any number you pick and stick in there is going to work, provided it's a real number. Okay. I think that's the last screenshot. Yep. There's your homework. Thank you for your patience, and have a great one. Come on, camera, pop up. There we go.